So what we're doing basically is to, on these cruises, is we locate the tagged whales using the Argos map here that we get from the that I get from the data on the website. Then we actually have to find the whales because basically we don't get a location all the time from the whales. It's I won't get into all the gory details, but basically every few hours we'll get a location, and then once we get that location, we actually have to find the whales visually, or we use our towed array. So this is one of our team members on our 25-pound binoculars that we have mounted on the flybridge of the ship. So part of what we're trying to do is determine winter diet from predation events. We do that in a small boat that we launch from the Shimano. This is us down off the Oregon coast following the whales to scoop up poop. This is kind of what it looks like. Person up in the bow pulpit, the whales out in front. And this is actually a technique that we developed up here in the San Juan Islands. We started back in 2004, and we've been actually collecting this data longer than 2008, but we published a study in 2010. We were interested in looking at the foraging behavior of the whales up in that area. And this was based on a technique that John Ford had developed, basically scooping up scales. But one of the things we found out really quickly was that the whales were converging a lot of the time and likely prey sharing. And when they do that, they tear the fish up and they leave a lot of scales in the water. And they also leave pieces of tissue. And the other thing we found was that they also leave poop in their wake, which is probably not a big surprise. But the use of those two materials actually, we needed to undertake some molecular genetic techniques to be able to take full advantage of those different materials. So this is typically what we've been getting is just salmon scales. And so our goal up in the summer was to get a sufficient sample size to get an idea of what the whales were eating up there. And basically what we found was that they're primarily Chinook eaters. And that was a cool another story. But I'm going to tell you a little bit about what we found here in Puget Sound. I'm glad Mark and Meyer here tonight get a chance to see some of the samples that show up on a map here. These green dots are Chinook samples. These yellow dots are chum. And then we have also coho and steelhead. The interesting thing is if you look at the scales and tissue, October, November, December, you see primarily chum salmon is green and then some Chinook salmon. But we've developed a new technique called quantitative fecal DNA, and basically we're able to quantify the amount of DNA from different species of fish and from the feces, and it's a little bit different story. And we see actually a fair amount of coho in October, and then about the same amount of chum, and then about the same amount of Chinook. And then actually in November, it's almost an even split between Chinook and chum, which is very different than what we were seeing with the scales and tissue. And by the same token, in December, it looks a lot like what the scales and tissue were telling us. So anyway, that's the same technique we were going to try to use on the outer coast. So in our 2013 cruise, when we were able to follow Cape Cod, we picked them up down here off the Cape Blanco, and we followed them for 8 days up the coast of Washington. And these red dots are predation samples, and basically we were able to collect them all the way from essentially Tillamook on up north. We also got a couple of samples from Northern California from a colleague of ours that lives in Arcata. Basically, most of these samples were Chinook, but they also included steelhead and chum. And then with the Chinook, we're actually able to identify what watersheds they come from. And this included the Central Valley, the Klamath, several from the Columbia River, as well as Puget Sound. Now we were able to do the same type of analysis that I was just talking about, where we looked at the scales and tissue. So the two samples that we got in January from California were both Chinook samples. But it's interesting to see here that Jeff also got a fecal sample down there, and there was a little bit of lingcod in that. Now you look up here, and we basically have primarily Chinook, some steelhead, a little bit of chum, and a little bit of lingcod. But down here, what you actually see is a bigger contribution of lingcod and halibut to the diet, as well as some steelhead. So the feces tells just a slightly different story. The other thing I really wanted to emphasize was that where these fish are coming from. As I mentioned before, they come from the Central Valley, the Klamath, the Columbia River, and Puget Sound. These are all big watersheds that they're coming from. The fish that they eat in the summer basically all come from the Fraser River. So the recovery of southern resident killer whales is going to depend on recovery of salmon in a wide variety of areas. It's not just local areas. I was asked to give a talk last year about what the Elwha production was going to do for southern resident. It's great. It's going to be wonderful to recover the Elwha. The Elwha is going to produce 16,000 Chinook salmon at best. It's all based on the size of the watershed is what the productivity is going to look like. So there's no question about it that the Elwha is pristine. It just doesn't have enough habitat to produce salmon on the same scale as either the Columbia, the Fraser, or the Central Valley or the Klamath. So what I'm trying to do at this point is get everybody to realize that the recovery of southern residents is really going to depend on a western United States recovery of Chinook salmon. So, back to critical habitat. So, K-Pod in 2013, all these little red dots are where the whales spent most of their time. Like I said, I was just talking about the Columbia. Look at all the red dots off the Columbia and on up to essentially Westport. They spent a fair amount of time up here off the north coast of Washington, northern California, near the mouth of the Klamath, as well as at various river mouths down in northern California, which also happen to be very good steelhead rivers. So this is what the range of K-Pod looks like based on K25. So, but the real question is, was that representative where L and J pods move? And what portion of K-Pod's range should be designated as critical habitat? So we sort of broke the door open with K25 data, but the question is, was just that an anomaly, or are we seeing similar things with other whales? So, in December of this year, just this past year, we tagged J27, and again, this was designed so that we could try to get out with them, on the cruise. We caught up with, on February the 11th, we left Newport, and by the 13th, we were able to get up and get on J27 up here in the northern Strait of Georgia and spent 3 days with them. And I'm going to try an animation one more time because I really like these things, but no. Oh, don't do this. Oh, here we go. What you're seeing here is actually we combined L87 from last year and J27 from this year. And they're on the same, here's the calendar going, so this is early January. The fascinating thing to watch here is that these whales spend most of their time in inland waters for the first 2 weeks before they make any run out to the outer coast. They spend a lot of time up here going around Texada Island, then back into Puget Sound, and finally here we are on the 12th. J27 makes the first run out to the outer coast. L87, which is part of J-Pod, at the same time makes a run out to the outer coast, spending a lot of time up in the northern Strait of Georgia. And then we'll come up here and let's see, L87 is going to stop right about now. Just when it got interesting. J27 is going to continue to go. And it's going to sort of get a little jumpier because we had to duty cycle the battery, so it'll fire up every 2 days. So it sits there for a little bit. But the interesting thing is that here in a second, it's going to come back out to the outer coast and it's going to make a run out to the continental shelf. It's going to go up here and then go clear up around up to Tofino. Since it's 4th, it should do this here shortly. Here we go. Out to the continental shelf, up to Ucluelet, back down, back in. Now it'll come back out and make a loop around La Perouse Bank out here. And this is about the time, the 12th. Now we're in hot pursuit with the Shimada, and we catch up with them finally up here. And that's the end now. The interesting thing is couple more days here, I'm going to put J26 in, and it should start up on the 21st. And it basically was tagged there and then moves out, does that 3-day loop, and that's the end of the animation. But the interesting thing to show you is where the concentrations of activity are. The fascinating thing to me is that's the entrance to shipping lanes for Puget Sound out there at the entrance to Strait of Juan de Fuca. It's a horribly noisy place, yet the whales seem to spend a lot of time out there. So anyway, but the main thing is just to keep in mind that J-Pod now has a very different distribution than what Ks and Ls have done. So one of the bonuses of being on this cruise was we're trying to document various killer whale behaviors. We were able to follow up checking on J50, which was one of the new calves that Donna mentioned, and we also got the second look at J51 up in the Straits of Georgia. So that was really exciting to see that the calves were doing well. One of the other things we try to do is monitor what the tag condition is on the whales. This was the 14th of February. You can see the tag is just about out of the fin, and on the 15th, the tags come out. So one of the things that we try to do is make sure that there's, monitor what the tissue condition is. And so when the tag came out on the whale, the next day we took off because at that point we didn't have any tag on J-Pod. We had a report of Ks and Ls down off of Sioux Harbor, which is just to the west of Victoria. So we had the acoustic array, which is right here. It's in this clear tube here, and we tow it about 100 meters behind, or 200 meters behind the ship. Put that back out, and we basically were able to intercept the whales down off of the entrance to the Strait of Juan de Fuca. The way this works is the array is towed behind the ship. There's a series of hydrophones in it. We have some software where we can listen for various types of either calls or echolocation clips. And then we have a program called Ishmael that is a tracking program. Basically, it allows us to get bearings to figure out where the whales are relative to the ship. So I'm going to try one more thing, and that's these audio clips. So usually it's the audio clips that are problematic. So we'll see if these work. Sounds like a bunch of sleepy balloons. And then the other thing we can listen for is a combination of calls and clicks. They do sound really fun. And as I mentioned, one of the things we're interested in looking at is behavior. And so these guys are just like bats when they have these feeding buzzes. And I get the mouse back here one more time. This is a very short clip, but it sounds like a machine gun going off. So that's basically a feeding buzz. So as I mentioned, we were able to go out to the Strait of Juan de Fuca. We found Ks and Ls. Within about 2 hours, we were able to launch the boat, get out, and put a satellite tag on L84. And that allowed us to follow the whales for basically 12 days, from the 17th of February to the 1st of March. So the questions we were looking at were, was L-Pod going to use the coastal waters of the U.S. just like K-Pod did? Where are they eating? What are they eating? Will they meet up with other L-Pod whales? And so this is just a track that I pulled off Argos today, showing the whales going clear down to Northern California over the last 20 days. We're at day number 38 now on L84's transmissions. We're hoping for, hopefully another few weeks. So, as I mentioned, during this cruise, we were able to actually collect a whole series of additional data that will complement the data before. It's way too soon for the analysis to be done, but we collected 21 predation event samples, 9 fecal samples, and somebody must have had a cold because we got 7 mucus samples. And we also collected 4 biopsy samples. Now the biopsy samples are interesting because we can use them for a variety of different things. We can use them for contaminant analysis, we can do genotyping for parentage, we can also look at their stable isotopes and look at the trophic feeding level, and we can also determine the age of the whales from this. So just a little bit about the contaminants. One of our big concerns, as I mentioned before, is that these whales are relatively contaminated. This is some J-pod whales and L-pod whales. This is PCBs and PBDEs. These are flame retardants. PCBs are basically have been used in transmission systems for cooling and whatnot. You'll notice that they're above this red bar, which is where we observe health effects on harbor seals. PBDEs are higher in J-pod, particularly in the juvenile animals. We think this is because J-pod spends a lot of time in inland waters where they feed on fish and whatnot that are essentially in the local food chain. PBDEs, because they're flame retardants, are essentially associated with urban areas. The other thing that we can look at is, if you look at the DDT to PCB ratio, what you see is a very different pattern, the gray bars versus the black bars. This is J-pod, that's L-pod. What this tells us is that essentially L-pod is eating something different than J-pod. And what's going on here is that DDT was released from the Southern California bite when it was manufactured down there. So there's a line of it up the California, Oregon, Washington coast. So basically, L-pod is eating fish that originate in California based on the higher DDT levels. The other thing we can do, as I mentioned before, small population size was a big concern. There's a very small number of males that are essentially responsible for most of the breeding. Most of the recent breeding has been done by J1, who is now deceased, as well as L41. And this is just a tree of showing the connection of those two whales to a variety of different females and their offspring. Final thing I wanted to mention was just the stable isotope, because stable isotopes in the skin basically cycle through over a 2-month period. So here's the stable isotope of Chinook salmon, coho, chum, steelhead, and sockeye. Here's the killer whales in here. What this says is if these dots were up here, it'd be a 100% killer whale diet. Well, I've already showed you that they do eat some other things. What they don't eat a lot of sockeye during the summer, but you'll notice that chum and steelhead are down here. So what's probably happening is that the whales that are consuming more of that than what we had previously thought. So one of the things that we got a lot of time to do is spend time with the whales over 2 weeks. It was an unprecedented opportunity to basically spend 24 hours a day, 7 days a week. As I was telling Donna, we're basically doing science at about 3 to 4 miles an hour. We spent a lot of days with the whales. They were just swimming along. This is up, basically we followed, as I mentioned, J-pod up around in northern British Sea, and then we followed basically followed L-pod and part of K-pod down the Washington coast all the way to Oregon and back up to the push. So this is just some photos of the whales as they're spending a lot of their time just swimming along. The lower photos down off the sand dunes in Oregon, and as I was telling Donna, if you look real close, you can actually see people on the beach, except that we had no reports of anybody seeing the whales, yet they were right there next to the coast. So we just got to get people out there with binoculars. We saw a lot of whales spending a lot of time traveling, resting, foraging, socializing. Some days they were grouped up tight like this, resting, like the photo below. Other days, at other times, they were extremely spread out. One day we had whales basically all the way up against the beach, and then 3 miles offshore and 6 miles south of us. So they spread out. We think of them being spread out in inland waters. It's a whole different dimension out there. We also saw some activity out there that was really interesting from the standpoint that sometimes for just no reason at all, they take off porpoising along. And down in Oregon, we were down there in a couple of days when it was pretty rough. Whales seem to enjoy surfing in the waves. And one of the things we saw we couldn't understand was a situation where all of a sudden the whale would be swimming along, and it was like, the only way we could describe it was that somebody hit the breach button. And all of a sudden, multiple whales would start breaching, and it would just look like depth charges going on all over the place. So multiple whales doing multiple breaches all over the place for about 5 or 10 minutes, and then they just stop and go back to swimming. And there was no acoustic cue, nothing. It was just like, so as I was telling Donna earlier, it's kind of like there's a whole bunch of things that were fascinating about this trip, but I'm actually sort of frustrated because I had this great opportunity to learn a lot about the whales, but I'm not sure I understand exactly what they're doing yet. So I just wanted to mention, we also were conducting these seabird surveys, zooplankton data was being collected. There was a Lazon's albatross that we saw on the cruise. We also ran in some Rizzo's dolphins one day. We collected a tremendous amount of data. But the highlight was running into L121. And so it was really fascinating because about 3 days before we ran into him, I got an email from John Scordino, who's a biologist out with Macaw tribe. And John sent me a picture of a killer whale with an open saddle on it that he had taken a couple of days before that. It turned out it was L25. And as I mentioned, we didn't have all of L-pod whales when we ran into them. And so Candy and I were talking about, we thought, God, wouldn't it be really cool if they actually all got together? And sure enough, we were 15 miles off of Westport on the 15th of, or on the 17th of, or I'm sorry, the 25th of February. And all of a sudden, L41 comes up. Well, we knew L41 always hangs out with L25. And it's like, we got more whales here. But the really interesting thing was that all the whales were all sort of bunched up together. And they weren't just resting, there was a lot of activity. So sometime in the night, all these whales had gotten together. And all of a sudden, right in the middle of that group, L121 pops up. And we were really lucky to be able to spend some time that day and then the next day. And I think what I was going to do is finish up and answer questions, but I'm going to switch over and I'm going to show you a short video that's not embedded. And and this was some of the footage that we shot. I'm hoping that this will work. This was actually the thing I was mostly concerned about. We might take a second for it to fire up. We were lucky to have brought a 4K resolution camera along. Sorry if it's not a little steadier. Hope nobody gets seasick. So this is right off of Westport. So there's mom, there's sister. So we think the calf is probably about 3 days old at this point. We can still see the fetal folds on the left side. As you can see, it's very, very active, throwing its head up there to get a breath. It is cute.
You weren't able to sex the cat, huh? Did it roll over for the
It rolled, what you couldn't hear on the audio was when it rolled over there, just when it slapped its lip, it was like, oh, keep going, keep going. Anyway, you can hear me. Okay, so like I say, I'm done. Back to questions. In the back there.
Hi, how far will the orcas spread out before, is there like a limit to how far apart they'll get? And is it related to maybe they can't hear each other anymore?
Well, that's a really good question. I mean, I was dumbfounded at how spread out they got. I don't know what the answer is to how spread out they can be. I would have thought that they would have been out of acoustic contact, at 6 or 7 miles. But, the weird thing was they weren't vocalizing at that point. So somehow they know how to get back together. I was telling Donna earlier, we had a 3-day stretch on this cruise where nobody made a peep. Whales swam all the way, they were off the Columbia River one day, they were all bunched up, and this is one of the reasons that collecting this type of data is so important, because, you know, you saw how there were all these tracks around off the Columbia. I showed you that it's a very important area, so we just assumed that they're foraging there. We spent one day where the whales were all basically, and they didn't look like they were resting. They would come up and they'd kind of turn to the left, and they'd come up and they'd turn to the right. They were all, and when we went back and looked at it, they were in a box, basically, that was 1 kilometer on one side by 2 kilometers on another. And nobody made a peep. And then all of a sudden, they all upped and decided to swim to Oregon. They went all the way down to the mouth of the Umpqua River, and then without making a peep, they all decided to turn around within 10 minutes and head back north. And then finally, when we got back up to the Columbia, they started vocalizing again. Like you say, some days I feel like I have no less than when I started. but it's going to be, a lot of it's going to be going back and looking and listening at things. So, but, you know, back to your question, these guys can really spread out over big areas, and I don't know how they necessarily, you know, we think that it's the calls and whatnot, but maybe there are percussive behaviors and whatnot that they're doing from time to time that essentially orient them back to each other.
Do they have meters?
Hang on, I'll get back to the second. Buzz?
When you were showing the distribution of different prey items in November and December,
Yep.
I think it was Chinook and coho
Yep.
that they were eating mostly in those 2 months.
Well, chum and Chinook mostly. The coho were leading in, you know, in October, right? Yes.
Okay, but when you get into December, were those samples that were taken in Puget Sound?
Yes. Yes. Yeah, those were samples. Now, having said that, the feces, when the whales ate those meals, may have been outside of Puget Sound, because one of the things that we don't know is how long it takes for the fish to get through the intestinal tract. So I've talked to Jim McVeigh at SeaWorld. They've done some passage rate studies. He says it can be as fast as 3 hours. So, you know, we're not sure. Just kind of based on basic biology, you kind of think about 24. You know? But anyway, that's actually a study that we're hoping to try to do at some point. So somebody asked about leaders. Good question. I don't know that we necessarily saw anybody leading the way. I mean, J2, for instance, usually is out in front of J-Pod. I'm not sure that we saw that sort of pattern with K's and L's. L25 is probably one of the oldest, and again, these guys have been separated off from the other part of L-Pod. That's one of the things that's it's really hard to tell sometimes, is that they can be so spread out that there were days when we didn't see all the whales that were there, because they were. So what we would do is we'd have the Shimada offshore of us. They didn't want to come into shallow water because they're towing the array, so it's really quite shallow off the Washington coast, and so they needed to stay in a minimum of 40 meters of water, which means they need to be about 3 miles out. We were bringing the small boat in, telling some other folks earlier, we were actually in 8 meters of water off the mouth of Willapa Bay, and the whales were killing fish in there. So it's really interesting that the whales are coming into very, very shallow water in some cases, but other whales are spending, time way offshore.
So I've heard that climate change is affecting transient whales, killer whales.
Mm-hmm.
What about the residents? Do you have enough data to see any changes at all since the water temperatures are changing?
Well, this is a really interesting opportunity this year, because the Weather Service finally got around to declaring El Nino year. I could have told you that in January when I put my snow skis away for the year. But so it's going to be one of these things where we're going to take a look at this year's data and say, okay, so this was an anomalous year in some ways. How does it compare with what happened in 2013? So the whales did go down to Central Oregon, then turned around, went north. Then they went down to Northern California. They don't seem to spend a lot of time a lot of times, and so one of the things we're trying to figure out is, it's like when you're a fisherman, do you leave fish to find fish? And so do the whales do that? I have a hunch that the whales do exploratory runs from time to time. In other words, even if they've got fish, they'll go somewhere else just to check things out. And it's kind of like when jays go out to the entrance to the Strait of Juan de Fuca. It's almost like they're going out there, because basically what Chinook salmon and most salmon do is they come out of the rivers, they turn right, and they go north. So if you look at John Ford's data, he actually gets a lot of Columbia River fish that northern residents eat off the northern Vancouver Island. So basically, a lot of those fish are up there, but when they start returning to the rivers, they're coming in from the north. So, but, you know, why the whales are moving the way, the patterns that they're doing, you know, I'm not sure. But essentially, back to your question though, Chinook salmon and many other species of salmon it's going to be very challenging for those stops with climate change, because climate change in the Pacific Northwest is going to mean lower snowpacks, I mean warmer river temperatures, those types of things. And all the scenarios that I have seen basically point to reduced salmon runs, and that's not going to be good news for killer whales. And you know, you look at California right now; they're in a horrible drought situation. That means probably a collapse of salmon runs in about 4 years. So the whales have evolved to that sort of scenario, but the trick is going to be, do we have enough options for it? So, you know, if Chinook that are available in the winter typically in California, if those fail, then in the Columbia River spring Chinook have a bad season, and then the Fraser River spring Chinook have a bad season, you're talking about a period of over, say, 4, 5, 6 months. Killer whales need to eat basically, not all the time, but they can't really go for, you know, they're not like the lean whales where they can bulk up. They have to eat periodically. And we think that that's maybe one of the issues that the population is struggling with, is that, yeah, they're getting enough, but not enough to be robust. And that they're just on sort of a lower nutritional plane, which sets them up for being susceptible to diseases, particularly with contaminant levels they have. And that's kind of where we're at. One of the things we're going to be doing here in about a month is we're going to have a health assessment workshop on southern residents and take a look at, you know, what do we know, what do we don't know, and then try to target some of our research toward trying to understand, you know, how things are, you know, how does maybe being on a lower nutritional plane affect them, what's the role of contaminants, what's the role of disease, because we basically got a reproductive, you know, success problem, and we've got a survivorship problem. And particularly that dip in the 1990s that I showed you coincided with a major dip in Chinook salmon production up and down the west coast. Yes, sir.
Is that is the diet of wing cod maybe the reduction in salmon runs responsible for the diet of the somewhat diet of wing cod, or is that something that they've always kind of fed on and
Well, that's a really good
just
question.
unknown, you know?
Yeah, I think it's unknown. I mean, it was kind of a surprise to us that they, you know, well, in that lingcod are probably a good, you know, nice big beefy fish to eat, but, you know, the fact that they were actually, you know, getting 15% of the diet on the outer coast was kind of a surprise. But it was interesting because when we first found this, guy that I work a lot with that did all the animations and whatnot, who's our GIS guy, he just happened to Google lingcod, and he found this really interesting article that says that during the winter, as it turns out, lingcod males are particularly susceptible to spear fishermen, it said, because they guard their nests. And so he sent me this article and he crossed out spear fishermen and he put killer whale. Because basically, you know, if these males are defending their nests, you know, basically these killer whales could come along and knock them off. So, yeah, I mean, it's, you know, it's interesting to me that the whales in many ways are very hardwired toward wanting to eat Chinook salmon. Yet, they're really smart whales, and they can be plastic, but it's like, you know, they just don't, it's, at times you kind of wonder why they just don't eat other things. It's like, jays and owls have been documented killing harbor porpoise. Now, they're not transients, but they will kill harbor porpoise, but they won't eat them. They'll just pack them around like a little toy, and then they discard them. But why don't they eat them? I mean, it's just, you went to that much trouble, you know, and it is protein. But it's just like, in some ways they're hardwired, in other ways they're plastic.
It doesn't also seem like they ever eat pink salmon.
They will eat pink salmon up in, John Ford is documented eating those, but apparently it's just the juveniles that eat pink salmon. Now, how many of you like to eat pink salmon? Do you like pinks?
Oh, yeah.
If they're fresh and they're cooked right,
They're
they're
also
fine.
cheap,
Yeah. Well,
and
this
there's
is,
6 million of them that come into Puget Sound every other year.
no, that's a good point, but, I mean, this is one of the things that I've had a lot of, I guess discussions is being a nice word, I think arguments is probably, I've talked to a lot of salmon managers, and they're all telling me, well, look, there's all these salmon that the whales could be eating, why are they, they must be eating like, I have, one of our biologists down in Olympia kept saying, is they've gotta be eating more sockeye, they just have to be. I said, well, Tim, I said, they're just not. I mean, they got up during the peak of sockeye season, and yes, they do eat a few, but not a lot. And we've got even, I didn't have time to get into it tonight, but I've got the whole same analysis that I just showed you for feces and scales for the summer, where we've really got it dialed in. But the point is that what happens is that sockeye actually come through very, very quickly. They're only around for about a month. They come in late July, and by mid-August, they're done. But the other thing you got to think about is what the different behaviors of salmon are. Now, Chinook are basically down near the bottom. Now, we have documented through a DTAG, and that could be another talk I could come and give, because we've got some great animations now of the whales diving down to 150 meters and chasing fish around down at the bottom and coming up, and we collected the scales up at the surface. So we know the Chinook are down deep. Now, one thing I can guarantee you, we found out the hard way in 2002, is when you put a critter cam on a whale, and you send the whale down to 150 meters, it's dark. And you don't see anything down there. So that probably works to the Chinook salmon's benefit in being dark. But of course, the whale has all this acoustic capability. But think about it from the standpoint, if Chinook are down deep, what do sockeye and pinks, all that sort of stuff do? They all spend their time up near the surface, and they're up in the photic zone. So, but what do? They all school. So that's an anti-predator device. So the point is that it may be a lot more work to get some puny pink salmon than it is to get some nice big Chinook that you can share with the rest of your matriline.
I have the halibut and lingcod. Did you observe that on this year's cruise, or documented on this year's cruise, or is that from a previous year's
That was
cruise?
from the 2013. So we don't have the data back. We're just starting in. But I can tell you that I collected some stuff this cruise that wasn't salmon. Yeah, it was another white fish. And I think that they killed a halibut that we collected some tissue from.
I
So
hope so. I'm glad to hear that they'll eat something.
I'm glad to hear that. I'm just glad that they're not taking them off the long lines like northern residents do. So. Other questions? Right here.
How did you become a scientist?
How did I become a scientist? Well, a long time ago, there was a whale named Namu that came to Seattle. And I was 10 years old, and I was just absolutely infatuated. I would go down 2 days a week to the Seattle Aquarium and spend all day watching a whale, and I never got bored. And you know what? I'm doing the same thing now, except I'm getting paid for it. You ready to cut me off?
No, why not?
How do you get to attack on the whales?
How do you get the tag on the whales? You have to be extremely patient, have a lot of adrenaline. It's really critical to match the course and speed of the whales, approach them very, very slowly. We have to get within 8 meters of the whales. So it takes some very, very careful. So I drive the boat. I don't do the tagging itself. We have our colleagues from Cascadia Research who have, years and years and years. They've tagged hundreds of whales, so they're very good shots. And we just basically slide up very slowly next to the whales, and we just pretend like don't pay any attention to us. and then the tag goes on. We usually get a flinch out of whales and maybe a quick dive, but most of the time the whales come right back up near the boat. So it's not something that's a major traumatic experience for them.
Are those Olympic tags?
Yeah, they're the Olympic tags. That's the name that Russ Andrews developed this tag. Calls it, and it's the low impact, some externally mounted something or other. But it's a wonderful tag that has been developed for. And as you can see, it's basically given us just this absolute quantum leap in understanding over the last couple of years in terms of going from not having hardly a clue about where the whales spend their time to starting to know what the pattern looks like to a certain extent. So, I mean, we still got some gaps to fill in, but it's really, really exciting to be at this point, at this point in time, because I kept thinking, how long is this going to take us to actually do this? And, we were very, very fortunate, and as I've told a lot of people, I'd rather be lucky than good any day of the week. But, we got good weather in 2013, we got good weather in 2015. It made all the difference in the world in terms of being able to spend time with the whales. We've got a ton of data to be able to take a look at now, and so we've got probably a total of almost 50 price samples from the outer coast, and close to 30 fecal samples. So that's going to go a long ways toward helping us understand what's going on. It's still snapshots, but by the same token, when you go from essentially 30 sightings total for the outer coast. And the other thing, as I was telling Donna earlier, as I didn't have time to talk about, is we've got acoustic recorders all over the place on the outer coast. So we'll be able to take the satellite tag data and the acoustic recorder data, and I'm hoping basically construct, essentially movement maps over longer periods than what the satellite tags tell us.
So they must know you're following them. Are they curious, or do they ignore you? How do they act towards you and your boat?
Well, that's a good question. We have, our boat has, it's a 22-foot Zodiac with twin 90s Hondas on it, and it's probably these guys are very acoustically savvy. So I'm sure that we pulled up next to them in Cape Blanco, because we spend all summer, not all summer, we spend 3 weeks of summer with them. They must have got, what are these guys doing here? But they really don't, we don't sense that there's any issue with them. As you saw in the video here, the calf came up right behind with mom and whatnot. We were basically in neutral and the whales came over the boat. We were trying to basically match course and speed. We don't see any reaction, as far as their behavior relative to us. So, we realize that, they're probably aware of us, and there may be some, there are some whales, I should say, that you can't get very close to. I mean, because we do try to collect biopsies from some animals. Other animals are just, under the bow all the time. This is like K33 is a really good example. He's just always right under the bow for some reason. I don't know, or in the wake or whatever. And some whales, I think, are probably a little bit more boat tolerant, I guess, and other whales just aren't, into it that much. So, another question right here.
Do you know who Echo is?
Do I know who Echo is? I don't know.
That's J42.
Oh, thank you. Very good. I hate to admit it, but I don't know the whales that well. There's one of the people on our team, Candy Emmons, worked for the Center for Whale Research for 10 years, and she can identify the whales at like 100 or more feet away, coming up like this, with just the edge of the dorsal fin. And on a good day, I can get the males right. So, what's that?
She's in the J pod.
Very good, very good. Okay, other questions?
Yeah, I was just thinking about your question because of the traffic. Are you also monitoring the sound of the traffic of other, ships around you, like the big ships or?
Oh, when we're out on the outer coast? Yeah, the interesting thing is that we're picking up all sorts of ambient noise. The funny thing is that there's just not a lot of ship traffic where we're at. There's a fair number of boats. What we found out the hard way is that there's a lot of crab pots in that area. We had 300 pounds of crab gear wrapped around the shaft of the Shimano when we got back in. And then one of my colleagues down there had spent the next week calling fishermen because they have their number on the pot. So he had to call them up and tell them that NOAA was sending them a check for their gear. But it's funny, despite all the boats on the outer coast, I think we had 2 fishing boats that actually noticed the whales the whole time. I mean, it's just amazing to me, despite the fact that you think there's a lot of boats out there, there really isn't. And even those that are in the vicinity, a lot of times the whales are so spread out that they don't see them. Or you know, in those rare cases, what they do, they may not have a camera and they don't take the time to call. But that was, despite the fact, like I say, there's bazillions of crab pots out there. And as you saw in the video, the whales were swimming right through next to the crab pots.
Do the whales ever try to come up the Columbia or a big river mouth like that?
There's a record from 1932 of a killer whale going up into the Columbia. I don't know how far up it went in, but of course, being 1932, they promptly went out and shot the whale. Because that's just what they did back then. But no, they typically don't go up into fresh water. I mean, the whales seem to know that, you know, that's the situation. It's just like, you know, they go right up the mouth of the Fraser River, take a right, so on and so forth. Behind,
You may not know this, but what is our oldest male that we know?
L41, I think he's 34.
34. And how about the J male with the real rugged dorsal fin? Has he ever come back, or there was one that we've lost?
J1?
Yeah,
Yeah, he's gone.
he is gone.
Yeah, he's gone. There's a lot of people that think he's Elvis, but but he's gone. I hate to tell you.
34. Wow.
But yeah, so that's I mean, that's one of the things we're really curious about is why is it that females, and I mentioned that I didn't have a chance to. The data is still being worked on. I hate to pop everybody's bubble, but J2 is not over 100. She's not. It's just that simple. She's probably in her 70s or 80s, but she's not over 100. So our chemists are working on it. They've looked at it 4 different ways now, and it just the intersection of all the different analyses suggests that she's not that old.
You've got different pods. Do they communicate in the same language together? In other words,
Yeah, the southern residents have a common clan type of vocabulary, if you will. So they're using the same stereotypic calls. There's 36 stereotypic calls that they use. They're different than northern residents, different than transients. Even within the southern resident community, you have Jays using, you know, some that K's and L's may or may not use very often. So Candy Emmons, who I was mentioning, when she listens to our acoustic recorder, she can a lot of times say, oh, that's J-pod, or oh, that's L's, or that's K's.
Will that color on the baby orca change as it grows?
Yeah, it's going to bleach out to nice white. So
So that's typical.
that's typical, yeah, just from being in utero. They'll have that orangish, pinkish stain to them.
How much do the different pods interact with each other, or breed? Do they ever breed together?
Yeah, no, they're basically interbreeding all the time. So like L41, we know is bred not only with an L pod, but also with J's and K's. So probably, you know, it's hard to do the math on this to a certain extent, but the gestation period is 17 months for a killer whale. So you have to back it up like a year and a half in terms of when they get together. So the point is that, you know, they're together a lot in summer, but so 18 months means that they probably got to be getting together sometime in the winter, you know, for the breeding to occur. But that's, you know, that was part of the excitement on this trip is just nobody, you know, they get together all the time and split off and stuff in the San Juans, but we had never seen whales get together before on the outer coast. It was just fascinating, and all of a sudden, here's part 1/4 part Alpine, you know. And it looks like part of them may have split off. We're not sure, we haven't got all the photos yet from California, but it looks like, you know, it may have been back just to, you know, some unit, some subunit of L pod. L's tend to split up from time to time into different groups. So, and that's part of what we're trying to understand is because we want to make sure that when we designate critical habitat, we're in fact encompassing all the areas that the whales may use at a, you know, at a given time. But it looks like it's basically the continental shelf. But I think that, you know, the Washington coast in particular is going to be, you know, very, very important for the whales. And in some ways, you know, I think that that's good, and in other ways, you know, I have some concerns because of the variety of different uses that the Washington coast, you know, you know, there's lots of different user groups and whatnot, but learning that and being able to, you know, have that information to inform management decisions is going to be really, really important. I mean, a lot of folks, you know, have been critical. It's going to take us a couple of years to do critical habitat. We want to make sure we do it right. We want to make sure it's best available science. you have to remember, there's still people out there that are trying to get killer whales off endangered species list, such as cantaloupe farmers or whatever in the Central Valley. I mean, there are people out there that are trying to stop, the protections that need to be in place for the whales. So, and what that takes is hard science. You just can't speculate, and that does not stand up in the court of law. And I expect that a lot of things with killer whales are gonna end up in the courts. It's just the nature of the beast. I mean, we were there we've been there twice now on the listing, and I expect that that's gonna come back again, so.
You have mentioned the Swally Delta. Does that mean that the fish there, they're not Chinook? It's not a Chinook?
Well, Puget Sound's a little bit tough to figure out because there's been so much hatchery input into Chinook stocks. There's basically only two stocks of Chinook in Puget Sound now. There's North Puget Sound and South Puget Sound. I don't know exactly what the breakpoint is. We know that the whales eat Southern Puget Sound Chinook, which would include the Nisqually. But, the 800-pound gorilla in Puget Sound is basically the Skagit. That's where most of the Chinook are produced, and the vast majority of wild Chinook. So, but, one of the things I, again, try to emphasize, all the rehabilitation efforts that are going on in Puget Sound, they're all important. The whales, the more fish we put out in Puget Sound, the more time the whales are going to spend around here. Build it, and they will come.
I have a two-part question. How far back do we have data on populations of orcas? And the second part is the precipitous decline in population in the 90s. You talked about diet affecting that mostly. Can you talk about what started that decline and how it was how it leveled off, the major factors?
Yeah, that's a really good question. So, there's a guy by the name of Mike Bigg that pioneered the development of the photo ID technique back in the early 1970s. He started out primarily with northern residents, but also started applying it to southern residents. Ken Balcom then basically took up where Mike had started on southern residents. So by about 1978 or 9, Ken had figured out who all the southern residents were. Ken has been able to go back and look at some of the old footage from the captures that occurred in Puget Sound. So you have to remember that that there were about 48 whales taken out of the Puget Sound population in the late 60s, early 70s. Most of those animals were about 3 or 4 years old. They wanted primarily small animals. It took out a huge swath of the juvenile population. So there was a dip in the early 80s, and if you look at that dip, that coincides with about when that part of the population was recruited in. So the legacy of the captures basically is still being felt in the population, and because we've lost a lot of animals and that reproductive potential. The decline we saw in the 1990s, we think, was really prey-driven. Because the population had actually come back in 1976, when Ken came up with the first estimate, it was thought to be 74 animals. We actually had fewer reproductive age females, and we had about 20 then. We now have 30. Now, the problem is that these 30 whales are not reproducing as well as the 20 whales did back in the 1970s. So that's the underlying question we need to solve now, is what's different now than it was in the mid-1970s? Because the population went from 74 to almost 90 whales. And then in the early 1990s, when we basically had, in 91, 92, our Pacific Decadal Oscillation flipped, and we went into this mode where essentially we had this warm water pool off the west coast. It just raised havoc with the Chinook populations, and they went to their lowest levels by about 1995, and that sort of rippled through the southern resident population until about 2001. Population had come back up to about 80-some animals, high 80s in 2011, and then all of a sudden the whales sort of fell off the cart again, and we declined back down to 78 here this last summer, and then now with the birth of these 3 calves, we're back up to basically 80. So anyway, yeah, those are some of the underlying issues. We don't pretend to completely understand what's driven the population at various times.
Based off of, what is your personal take on the orcas down at SeaWorld and how they would be introduced back into the wild? Do you think that's going to be successful if it happens?
standpoint that, I work on wild whales, and I actually was very much involved with the Keiko project. I did all the tag development work for Keiko and whatnot. There's a lot of things, I guess, we should have a sprinter talk again.
Yeah.
We should do that. Huh? Well, no, because there's a lot of people who don't know about sprinter. It's kind of old, it's like old news, but the point is that there's gotta be a lot of things going your way with reintroductions of animals. And one of the big issues is, we were really concerned about the sprinter was time separated from its relatives. And separating animals for decades and then expecting them to reunite, I think, is a tall order. So, there's just a whole bunch of things that need to be really very carefully thought through. This is one of the things that I saw with the Keiko project that, it was great to get him out of Mexico and out of Newport and get him into the wild and all that sort of stuff. But the bottom line was he was in the wrong place. Vesmanyar, where they had him, the whales there vocalized differently than what Keiko did. It was obviously the wrong population. But the point is that he was captured somewhere off the south coast of Iceland, an area that you couldn't really keep him in the winter because the weather was so brutal. It was bad enough at Vesmanyar, which is sort of the banana belt of Iceland, if you will, despite the fact that they have hurricane force winds during the winter about every other week. So the fact that that they kept the bay pen together was amazing. I was over there a couple of times, and it was all you could do was stand up straight because it was blowing so hard. But anyway, other.
I have a question about, is there any inbreeding going on? Do you have any data?
Well, that's a really good. It's a great question, because up until we started doing paternity on these guys, it was thought with northern residents, based on Lance Barrett Leonard's work, that they always outbred. Now, I have to remember that northern resident population is about 250 whales, and there's lots of different pods. So, there's lots of chances to outbreed there. With southern residents, on the other hand, that's not the case. You kind of, it's like, there's 3 pods. So J1, to his credit, didn't breed within his matriline. But he did breed within J-pod. We do know that. So anyway, and so we're just kind of at the point now, this is probably the most exciting time, is we have to wait till the calves are 3 years old before we can biopsy them. But we're going to be really interested to know now that J1 is gone, who actually has sort of stepped in. Is it all L41, or is it, other, because we've got lots of adult males, or well, I should say, these males become adult, physiologically at 15. But the question is, when do they become socially mature? When are they going to be able, because the thing with killer whales that's really fascinating is that, some species like that Rizzo's dolphin I show you, it's real clear what's going on there. Those males bite the crap out of each other. It's male-male competition. But with killer whales, the interesting thing to think about is that you've got secondary sex characteristics. Males are bigger than females. Males have taller dorsal fins, bigger flippers, so on and so forth. Something's driving that. So it's either going to be male-male competition, but you don't see these whales all scarred up. They're not biting the crap out of each other, because there's not a lot of scarring on them like you see on Rizzo's dolphins or beak whales or whatever. Or, maybe not so surprising, my vote would be for female choice, because these are matriarchal, female-run pods, and it's like, not you. I'll take you. So I think that's my own personal opinion is what's going on. But something's got to drive that selection for those features. Otherwise, they just look like the females. So somebody's picking whales for big fins and so on and so forth.
It should be noted that we hope that L41 is not the father of L121, because L94 is his sister. That's a little too close for that's like.
Yeah, exactly. We have to start the Kansas plan. But that's what will be really. That's all I'm saying is that we're at the threshold of a really exciting time in terms of pedigree analysis. But that brings up a really good point, because we are very much concerned about inbreeding in the population, because that, just like in human populations, inbreeding is a bad thing. The thing that's amazing about killer whales is that they are genetically very, very, very similar. I thought that, you know, if you plot out how different they are on a scale, if you compare them to bottlenose dolphins, bottlenose dolphins look like a tree. Basically, killer whales look like a stick. There's just no diversity. They are really, really, really genetically similar. Even with transients, and despite the fact that they haven't interbred with transients in probably 120,000 years. I mean, it's just amazing that the genetic diversity is still very, very similar. So, but the point is that diseases can take advantage of genetic similarity, and that's one of our two big concerns. The two big concerns we have for southern residents relative to catastrophic effects is the big zoonotic, disease thing going through the population, like morbillivirus, like we see in dolphins and whatnot on the East Coast or in Europe, or an oil spill. And those are the two big things that we're concerned are going to take out a chunk of the population.
So, how many orcas did they split up from sea to SeaWorld?
Oh, how many orcas did they split to SeaWorld? Well, the capture started in 1967, and they took about 48 whales. We think that there were probably, if we add up the whales that were still in the population with the whales that were taken out, there were probably about 140 whales back in the 1960s. So they took about a little over a third of the population. It's a lot.